Give a brief demonstration of the dynamic stiff string, which is here implemented in real time in Juice. And the string here is visualized as this dashed line between two square boundaries here. And I can excite the string using a raised cosine at different locations. So for example, in the middle or in the sides to get a different sound. I can then change parameters below here. The first one being the length. So if I just excite the string using the space bar now, taking the last excitation location, I can change the length while I excite the string. So from 2 meters to half a meter. All right, so putting this back at around 1, we can also change the material density. So I can turn that down, which is visualized as these dashed lines getting further apart or getting very close together when there's the highest value for the density. Then we have the radius, which is visualized using a thicker line for a higher radius and a thinner line for a lower radius. And apart from changing the pitch, it also changes the inharmonicity of the string, as this also affects the stiffness coefficient used in the stiff string, which is also scaled by Young's modulus here. So a Young's modulus is visualized using different colors, and for a high radius we get a very inharmonic or bar-like sound. And if we change this back to be completely 0, we have the 1D wave equation, the damped 1D wave equation here. We can vary between it. Then we skipped here one parameter, which is the tension, and this is visualized by rotating the boundaries either towards or away from the string, which decreases or increases the tension. Then here we have two damping coefficients. The frequency independent damping, we can set this to 0 to retain lower frequencies, and sigma 1 here to either retain or take away higher frequencies, which is the frequency dependent damping here. So putting that at its minimum value, we can get a very higher frequency sound here. Yes, then we can test the limits of this by changing some parameters very quickly to see how fast we can get from one grid configuration to the next. So we can start with the length. Changing that very fast. Then here's the density. Radius. Tension. Young's modulus here, maybe for a higher radius. And these damping coefficients, they maybe sigma 1 matters a bit for the amount of grid points, but yeah, the rest is fine.